Chapter 3: The Acid-Base Chemistry. Introduction. In this text, we are going to study acids and bases, indicators, strength of acids and bases, acids, bases and their reactivity, ionization of acids and bases, and more information about salts. Explanation. Acids and bases. Acids. Substances that are sour in taste contain acidic ingredients and their solutions are also acids. They turn blue litmus paper red. Bases. Substances which are bitter to taste are bases. They turn red litmus paper blue. Indicators. The acidic and basic nature of the compounds can be indicated by some natural as well as synthetic substances. They are known as indicators. The substances such as rose petals, turmeric and beetroot are called natural indicators. Some chemical substances such as phenolphthalein, methyl orange and eosine are also indicators. They are synthetic indicators. There are certain substances whose odor changes in acidic or basic medium. These substances are known as olfactory indicators. Mixture of several indicators is known as universal indicator. Strength of acids and bases. We can judge acidity or basicity by using a universal indicator. pH scale. pH helps in measuring hydrogen ion concentration in solutions. In pH, P stands for potens, means strength in German. The scale reads from 0, most acidic, to 14, most basic. The value of pH indicates acidic or basic nature of a solution. The strength of base is represented by pOH. When pH value is in between 0 to 7, the solution is acidic in nature. At value 7, the solution is neutral, and between 7 to 14, the nature of solution becomes alkaline or basic. When acids in aqueous give more number of H+ ions, then they are termed as strong acids. Weak acid. When acids in aqueous give less number of H+ ions, then they are weak acids. Strong base. When bases in aqueous give more number of OH- ions, then they are called strong bases. Weak base. When bases of aqueous give less number of OH- ions, they are called weak bases. Importance of pH in and around you. When the pH of rainwater is less than 7, the rainwater is acidic. When it flows in a river, it lowers the pH of river water. Aquatic life is drastically affected due to the acidic nature. Not only that, when this type of rainwater is absorbed by plants, it affects their growth, the flowers and the fruits they bear, etc. The human body works within pH range of 7.35 to 7.45. Our tooth enamel is made up of hard matter, calcium phosphate. Food particles are degraded by the bacteria in the mouth to produce acid with pH below 6. They corrode the phosphates to cause tooth decay. Hydrochloric acid produced in the stomach helps in digestion of food. The acidity or indigestion problem can be controlled by adding basic substances called antacids. Reactivity with metals. Activity: take a hard glass tube. Choose a proper stopper through which you can fix a gas passing tube. Take few pieces of Mg ribbon. Add dilute HCl to it. Take burning candle near the gas passing tube. Observe it now. Figure burning of H2O with pop sound, cork, test tube, bubbles of H2, gas, dilute HCl, Mg ribbon. The bubbles given out during the reaction are H2 gas. Hydrogen is displaced by the active metal from the acid. Metal combines with remaining part of the acid and forms compound salt. We can represent the reaction as acid plus metal gives salt plus hydrogen gas. Observation: when dilute HCl is added to magnesium, hydrogen gas is released. When burning candle is held near the gas passing tube, H2 gas burns with popping sound. Mg plus 2HCl gives MgCl2 plus H2 gas is released. Magnesium gives hydrogen. When iron nails are treated with concentrated HCl, we get ferrous chloride and H2 gas is released. Fe plus 2HCl gives FeCl2 plus H2 gas is released. Iron gives ferrous chloride and hydrogen. Chemical reaction between zinc and dilute HCl. Acid plus metal gives salt plus hydrogen gas. 2HCl plus Zn gives ZnCl2 plus H2 gas is released. Zinc gives zinc chloride and hydrogen. Activity: take a few pieces of aluminium ribbon in test tube. Add 3 to 5 ml sodium hydroxide to the test tube and heat. Observe and repeat the process with Mg metal. Reaction: aluminium plus sodium hydroxide gives sodium aluminate plus hydrogen. 2Al plus 2NaOH gives 2NaAlO2 plus H2 gas is released. When aluminium is mixed with sodium hydroxide, it gives sodium aluminate and hydrogen gas. Reactivity of acids towards carbonates and bicarbonates of metals. Activity: take 2 grams of aluminium carbonate in a boiling test tube. Add dilute HCl to it. Do not allow the gas to escape. Through the delivery tube, allow the gas to pass through decanted solution of chalk with H2O. Observation: Al2CO3 twice plus 6HCl gives 2AlCl3 plus 3H2O plus 3CO2 gas is released. Aluminium carbonate plus hydrochloric acid gives aluminium